Welcome. Today, we're diving into connection and importance, two ideas that shape how we relate, communicate, and find meaning. We'll explore what really makes us feel connected and why that matters so much in our lives and work. Let's get started. Today, we're focusing on why STEM matters so much. STEM, that's science, technology, engineering, and mathematics, is more than just subjects in school. It's critical for economic growth and keeping countries competitive on the global stage. STEM encourages creativity, sparks innovation, and builds strong problem-solving skills. It's also the foundation for future careers in industries that are growing fast. At its core, STEM is about hands-on learning, tackling real-world challenges, and working together to think critically and innovate. Let's dive into the key elements of computational thinking. First, decomposition, that's breaking a big, complex problem into smaller, easier parts. Next, pattern recognition, spotting similarities or trends that help us understand the problem better. Then, abstraction, focusing only on what really matters and ignoring the noise. Finally, algorithm design, creating clear, step-by-step instructions to solve the problem. This way of thinking isn't just for computer science. It's useful in science, engineering, and even social sciences. Let's look at how computational thinking fits into STEM. That's science, technology, engineering, and math. In science, it's about building models to simulate how nature works. In technology, it means writing code to create software or systems. Engineering uses computational models to design processes and systems. And math focuses on analyzing data and finding the best solutions. The key idea here is that computational thinking isn't just for computer science. It belongs in every STEM field, woven throughout the whole curriculum. Computational thinking isn't just for computer scientists anymore. It's a skill that crosses all boundaries, from STEM fields like engineering and biology, to areas you might not expect, like economics, healthcare, and even the arts. It teaches us to think critically, to approach problems with logic and structure. That's why it's so important in education today. It prepares us for the future, no matter what career path we choose. We're focusing on why these skills matter so much. Problem solving, programming, systems thinking, and data analysis. Employers see these as essential. They're the tools we use to tackle complex challenges, build and maintain systems, and make smart, data-driven decisions. Careers that rely heavily on computational thinking include software engineering, data science, AI and machine learning, electrical engineering, cybersecurity, and even biotechnology. These skills open doors across a wide range of fields. Computational thinking is at the heart of some of the most exciting advances in STEM. In environmental science, it helps us model climate change scenarios, giving us a clearer picture of the future. In engineering, it's about automating design and manufacturing, making processes faster and smarter. When we look to space exploration, computational thinking simulates trajectories and plans missions with precision. And in healthcare, algorithms predict patient outcomes, helping doctors make better decisions. These real-world applications show just how powerful this way of thinking really is. Integrating computational thinking into classrooms means more than just teaching coding. We want to bring problem-solving to life through hands-on projects that connect to the real world. It's about blending STEM subjects with computational thinking to make learning deeper and more relevant. To do this, we can use tools like online coding platforms, STEM apps and games, and robotics kits, such as LEGO Mindstorms. These resources help students build skills while staying engaged and curious. Computational thinking brings some powerful benefits to STEM fields. First, it helps us tackle complex problems by breaking them down into smaller, manageable pieces. This makes challenges less overwhelming and easier to solve. It also sparks innovation, encouraging us to think creatively and find new approaches. And finally, computational thinking promotes collaboration. It often requires teamwork across different disciplines, bringing diverse perspectives together to solve problems more effectively. These benefits make it a key skill for anyone working in science, technology, engineering, or math. STEM and computational thinking go hand in hand. Computational thinking isn't just a skill, it's the foundation for solving complex problems, which is exactly what STEM careers demand. As technology keeps advancing, getting comfortable with this way of thinking becomes even more crucial. So, let's encourage everyone to learn and apply computational thinking, not just in school, but in everyday life. It's a key step toward success in the future. Thank you for joining me today. I hope this talk sparked some new ideas and gave you a fresh perspective. Remember, every step forward counts. Keep exploring, keep questioning, and most of all, keep creating. I appreciate your time, and I look forward to where we go next.